The formula for exponential growth is A times 1 plus R raised to the power of T. A stands for the initial amount. R stands for the rate. And in this case, it's growth. So I'm going to put growth rate. T stands for time. All right, so the first example, the original value of an investment is $1,800. So that's your initial amount. So I know I'm going to have 1,800 times 1 plus, and I have to put the rate. It says if the value has increased by 7% each year, this is my rate. This is the rate. We're going to write it as a decimal. So what is 7% as a decimal? 0.07. Yes, you move the decimal over twice. So this will be 0.07. That is our rate. Find the value of the investment after 15 years. This is your time. So we're going to put 15 up here as the exponent. So everyone should have a calculator. You guys are going to type this into the calculator and figure out how much money this person has after 15 years. They started out with 1,800. Now how much do they have? 4,000.
Syntax error.
There we go. $4,966.26. Investing is wonderful. All right. Now, this was an exponential growth. Now let's look at exponential decay. Okay, so here is the formula. It doesn't change much, but since it is decay, we are subtracting the rate. This is still the same. Initial amount. This is going to be the decay rate. The rate of decay. T stands for time. So since this is exponential decay, we are going to be losing money. So we started off with $12,000. That's your initial amount. And we're losing value at a rate of 4%. So 4% as a decimal is 0.04. Find the value of the investment after 9 years. So for T, I'm going to put 9. This is what you will type into your calculator. You can also simplify this as 1 minus 0.04 is 0.96. All right, so guys, if you type that into your calculator, how much money do we have now? Yes, $8,310.41. They lost money. Okay, now we're going to talk about compound interest. Compound interest. So compound interest is calculated on both the principal amount and the accrued interest thus far. So before, this is just taking into consideration the initial amount. However, as you increase, they're going to take into account the interest as well. So this is why this one will grow a lot faster. Compound interest is much better than regular simple interest. Okay, so here's the formula for compound interest. And we have a lot of variables. P stands for the principal amount. Stands for the principal. And this is the initial amount. Same thing. Okay, R is still your rate. T is still time. However, the new variable that we have is N. N stands for the number of occurrences. And we're going to do it yearly. Instead of using the word occurrences, you can also use the number of times. Basically, the number of times it is compounded. Okay, compounded. It won't let me write the D. Okay, so let's do an example here. The initial amount is $12,000. That's how much Laura deposited into her bank account. And she earns 8% interest. 8% as a decimal is 0.08. Now let's talk about the N. You have to put an N value right here. It says, how much money will she have in 5 years if the interest is compounded quarterly? How many quarters are in a year? 4. So that's what it means by the number of times it's going to be compounded. It'll be compounded 4 times in the year. Okay? So I'm going to put a 4 here. And then it wants N times T. So that's 4. And how many years? 5. So this is what you're going to type into your calculator. We can simplify this a bit if you want to, or you don't have to. You can just type it directly. And then the 4 times 5 is a 20. Either way you type it in, you'll get the same amount. And how much money will she have? 40 cents? Okay. There we go. So she made a pretty good investment. This is how much her money grew. Her money grew about $5,831. That's $5,831 that she didn't even work for. She just let her money sit and then it grew. That's what's so good about investing. All right, next, we're going to talk about continuous compound interest. All right, the formula is P E raised to the RT. PERT is what we like to call it. P stands for principal. So in this example, it says suppose you invest $800. Well, that's your initial, that's your principal amount. Then you have E and your rate. It says 6% interest. So that will be 0.06 if you write it as a decimal. And then the time, it says 20 years. So times 20. This is what you type into the calculator. Okay, so when you type this into the calculator, you get $2,656.09. That's how much the money has grown in 20 years. Okay, now we're going to move on to some more problems. I'm going to do some more examples with you. Let's move to the back page. We're going to do this one. Okay, so we have to pay attention to what it's saying so that we know what formula to use. So guys, remember when it says compounded monthly, compound interest, remember the formula is the principal, 1 plus R over N to the power of T. This is compound interest. If it's compounded continuously, then this is your formula. PERT. When it's compounded continually. When you see the word continually, you use P-E-R-T. Okay? When it just says regular compounded, monthly, daily, yearly, whatever that they say, it's this formula. The distinction is the word continually when you use this one, okay? And then the simple one, I'll write it over here, was A1 plus R to the power of T. This was a simple interest, okay? These are the three formulas. Now, guys, based off of this problem, which one are we using? Yes, the top one right here. This is what we're gonna use. Okay, so it says how much money will be in the account after 6 years? Okay, well, we started off with 1,000, so that's my principal or initial amount. My rate is 4%. As a decimal, it is 0.04. Now, compounded monthly. How many months are in a year? That means we put 12 here. You have to think about it in terms of a year, okay? Since we're doing it monthly, that will happen 12 times in the year. Okay, so that 12 goes down there. This is also 12 times, time is 6. So this is what you will type into your calculator. Go ahead and give me a value, please. 1,270.74. Perfect. Okay, now it says, how long will it take for the 1,000 to double? If it doubles, how much are we talking about? 2,000. Okay, so we want to know, how long will it take for it to become 2,000? Well, the initial amount is 1,000. The rate is 0.04, and we're still compounding it monthly. So we'll still have those there. However, we don't know time because it's asking, how long will it take? So the only variable in my equation should be t for time. And we're going to solve for that. So what should I do first to get t by itself? What can I get rid of first? The 1,000. Let's get rid of this. Okay, so now we have 2 equals all of this. 1 plus 0.04 over 12 to the 12t. This is what we have now. Guys, please look. This is just a number. Can y'all tell me what number this is? What is 1 plus this fraction? It's just a number. Let's simplify it. 1.003 and a whole bunch of threes. Okay. Perfect. Okay, that looks a lot better. Now, let me remind you of something that we did yesterday, what we did the other day. Something that we did the other day, when we were solving these, we would take the log of base 2 and log base 2, and this would cancel out, leaving you just with t equals log base 2 of 10. And then you would put that in the calculator. We're going to use this same concept of taking the log of both sides. Here, since your base was a 2, we did log base 2. Going back to this example, what is your base?
2.
No. Guys, look, let me highlight this for you. This is your exponent. That means this is your base. The base is the number that has the exponent, okay? So our base is 1.0033. What I'm going to write is, I'm going to take the log of base 1.0033, and I'm going to do log 1.0033. I'm going to take the log of both sides. So this is what this looks like. First, you have 2 equals 1.0033 to the power of 12t. And we took the log of both sides. So we took log of 1.0033. Log of 1.03033. We took the log of both sides. Okay? This cancels out. We are left with log of our base 1.0033 of 2 equals 12t. Now, I'm almost done solving for t. What do I do to both sides? Yes. So guys, you're going to type this into your calculator. this calculates to become 17 point what? 53, okay, so this many years. Okay, so that's how many years it will take for you to double. Round to like 4 decimal places. Sure. Okay, so she invests 7,500. And it's compounded yearly. So this is the formula that I have to use. What is my rate as a decimal? Yes. 0.12. And it says yearly, compounded yearly. So what do I do? Yep. So basically it says yearly, that just happens once a year. So you don't really have to write the ones. And then the time is for 1 year. So this is another 1. So it doesn't really do anything. These are all just ones. 1 times 1. Okay, so guys, if you put this into your calculator, you can just put it in as this. 7,500 times 1 plus 0.12. And to the power of 1, you don't have to write the power of 1. What will this become, guys? 8,400. All right, there we go. Okay, how much would she have if the interest is compounded daily? So daily, how many times is that happening a year? 365. So this is still the same. This is her initial amount. Your rate is still 0.12, but now it's happening yearly as opposed to just one time in the year. So your in is 365 times your time. Your time is just 1 year. So this is a 1. Okay, so you'll type into your calculator. And what did y'all get? Thank you. All right, so that is how we do this problem. Let's move on to the next one. It says if $4,000 is invested at 7% interest, as a decimal, it will be 0.07. Per year compounded continuously. We see the word continuously, so we know we're going to use this formula, PERT. Okay, so my initial, and it says, how long will it take for the original investment to double? So it'll be 4,000. E, I don't need a parenthesis here. E, and your rate is 0.07, and then we have time. And we want it to double, so what should I put on this side? Now, guys, your very first step would be to divide the 4,000. And what will this side become? 2 for double. So, guys, anytime you're trying to double something, your equation that you'll end up with is 2 equals e to the rate times t. We saw this same step happen in the previous example. Here, when we tried to double it, this whole thing just became a 2. So what do you think will happen if you triple it? It'll just be a 3. Okay. All right, so from here, how do I get rid of an e? Yep, you're supposed to take the ln, the natural log of both sides. So you'll write an ln on both sides, natural log. This cancels out. We are left with ln of 2 equals 0.07 t. Now, how do I solve for t? Yep, divide by 0.07. So when you put this into your calculator, what do you get for time? When you type this into your calculator? 9.9, so 9.9 years. So basically almost 10 years. It'll take you almost 10 years to double your money. Okay? All right, the last one that y'all were working on. At what annual interest rate compounded continuously? So we're gonna use this one. Will triple your money in 9 years. A lot of you guys were asking, is this an extension of the last one? It really doesn't matter. No matter what say your principal amount was, give me a number.
5,000.
Okay, if it was 5,000, if it's tripled, what would be over here? 15,000. And then your first step is to always divide. So what does this become? A 3 for triple. It'll just be 3 equals e to the r9. It really doesn't matter what you start off with. When it says triple, it'll just turn into a 3. Okay? All right. So what do I do to both sides? ln and e cancel. So we are left with ln of 3 equals r times 9. Then you should divide both sides by 9. Can you guys type this into the calculator and tell me what you get? 0.122. Let's turn this into a percent. So yep, you move the decimal over 2 times, it becomes 12.2%. So that is your rate, 12.2%.